If you are listening to this, perhaps you are lying in the dark, perhaps you are looking for a place of rest, a small island of quiet in a busy world. I invite you to settle in to let the weight of the day dissolve. There is nothing you need to do, nothing to solve. There is only this moment and the space to simply be. Tonight I wanted to talk about some things I've been thinking about. Things that are so familiar we forget to see them. The world right in front of us, our own bodies, our own hands. We think we know them. But the more you look, the more you realize that reality is so much stranger and so much more magical than we are ever taught. Let's start with the simplest thing, the sensation of touch. Right now you can likely feel something. The softness of a pillow beneath your head or the weight of a blanket resting upon you. Or perhaps just the air on your skin. We call this feeling touch. It feels solid, real. It is our most fundamental connection to the world. And yet, it is an illusion. You have never in your entire life truly touched anything. And you never will. When you press your hand against a table, for instance, what you are feeling is not the contact of your skin against the wood. What you are feeling is a force. At the atomic level, the atoms that make up your hand are mostly empty space surrounded by a cloud of electrons. The atoms that make up the table are the same, and as your hand moves closer, the electron clouds of your atoms get near the electron clouds of the table's atoms, and these clouds, they push against each other. They are both negatively charged, and like magnets, they repel. That feeling of resistance, that sensation of solidity, it is just electromagnetism. It is a force field pushing back. You're in a very real sense floating, levitating just above the surface of the chair or the bed by a distance so small it is imperceptible. Your hand never merges with the table. Your skin never truly meets the blanket. There is always a space between. Every sensation of touch you've ever had, from holding a hand to feeling the rain, has been a conversation between forces, an invisible cushion of energy that keeps the world from falling apart and keeps you from falling through it. It's strange, isn't it, that the most solid things in your world are not solid at all? And that emptiness goes deeper. We say mostly empty space, but we don't really grasp the scale of it. We think of atoms as tiny hard balls like microscopic marbles, but they are not. The atom is almost entirely at nothing. Imagine an atom, the fundamental building block of your body and the bed and the air. Imagine scaling it up. If the nucleus, the dense center of that atom, were the size of a single peanut sitting in the middle of a vast football stadium, the electrons, the stuff that gives the atom its volume, would be like motes of dust clouds of probability drifting around the outermost seats. And in between, from the peanut in the center to the bleachers at the edge, nothing, just vacuum. You are made of these, trillions upon trillions of them. The chair you sit on, the planet you live on, it is all built from these tiny, impossibly empty stadiums. What we call matter, what we think of as solid, is really just this vast emptiness structured and held in place by invisible fields. Solidity is an illusion, a beautiful and convincing trick played on our senses by the laws of physics. You are not a solid object. You are a pattern. You are a structure of fields, a collection of almost nothings held in perfect, magnificent tension. But the illusions don't stop at the physical. They challenge our very idea of self. You probably think of yourself as a single being. One person, an individual. You look in the mirror and you see you, but biologically that isn't the whole truth. You're not a person so much as you are a planet. You're a walking, talking ecosystem. Living inside your body right now are trillions of other organisms. Bacteria, fungi, viruses, mostly bacteria. In fact, if you were to count all the cells, you would find that you are carrying around roughly as many microbial cells as you have human cells. Some estimates say there are even more of them. They are everywhere. On your skin, in your mouth, and most of all living in vast, complex civilizations within your gut. This is your microbiome. And they are not just passengers. They are not invaders. They are ancient partners. You have co-evolved with them for millions of years and you cannot function properly without them. They are necessary. They digest foods your body cannot. They synthesize vitamins essential for your survival. They train and regulate your immune system, teaching it what to attack and what to ignore. And perhaps, strangest of all, they influence your mind. There is a profound connection which we are only just beginning to understand between your gut and your brain. These tiny organisms living in your digestive tract can produce neurotransmitters, the very same chemicals like serotonin that shape your mood, your anxiety, your state of mind. So when you feel an emotion, is it just you, or is it in part a signal from the thriving invisible rainforest living inside you? It blurs the line, doesn't it? Where do you end and they begin? If they are essential to your life and even influence your thoughts, are they not? part of you. You're not a single entity. You're a colony, a beautiful, complex symbiosis, a universe of life carrying another universe within it. There is one more secret for tonight, one more layer of reality hidden just beneath the familiar. As you lie there in the quiet darkness, you are glowing. I don't mean that metaphorically. I don't mean you have a poetic aura. I mean quite literally your body is emitting light, actual photons, real physical light. It's called ultra-weak bioluminescence. It's not like the bright, deliberate flash of a firefly or the eerie light of a deep-sea creature. It is 1,000 times weaker than what your eyes are capable of detecting, but it is there. Incredibly sensitive cameras kept in perfectly dark rooms have captured this. They have taken images of people shining with their own internal light. This glow comes from the simple act of living. The chemical reactions in your cells, the normal process of metabolism, especially those involving oxygen, release tiny, tiny amounts of energy. And sometimes that energy is released as a particle of light. This glow flickers. It seems to follow a daily rhythm, often strongest in the late afternoon and weakest late at night. The face tends to shine just a little more brightly than the rest of this body. It's not enough to light a room. It's not enough to even see, but it is there, a constant silent broadcast. Every living thing is doing it. You are a creature of light in the most literal sense. Your cells are quietly and visibly announcing to the universe, I am here, I am alive. You are a collection of forces you cannot feel. You are made of an emptiness you cannot see. You are a home to a world you do not know, and you are shining with a light you cannot perceive. And this is only the beginning. This is just the journey into our own skin. Imagine what we'll find when we begin to look out. We have explored the strange invisible truths of the world beneath our fingertips. The illusion of touch, the vast emptiness within every atom, the glowing colony of life we call a self. But how did this intricate illusion come to be, this architecture of life? It is perhaps the greatest wonder of all. Let us go back before the first breath, before the first thought, to the very beginning of you. You did not start as you are. You did not start as a child or an infant. You started as a single cell. One. A microscopic sphere, barely a pinprick, floating in the dark. A cell called a zygote. And in that one cell, that one tiny simple dot, was everything that is now listening to these old words. The potential for the eyes that see, the ears that hear, the hands that feel. The entire set of instructions. Not just a blueprint, but a story, a process encoded in a molecule, a spiraling ladder of information. And then it began. That one cell divided. It became 2, and the 2 became 4, and the 4 became 8. A perfect quiet rhythm of creation. A cascade of growth. In the beginning, all the cells were the same. They were stem cells, cells that held the potential to be anything. But then something miraculous happened. They began to choose. This is the mystery of differentiation. As the cluster of cells grew, they started to receive signals, whispers, chemical gradients based on where they were. You're on the outside, you're on the inside, and based on these simple cues, they began to read different chapters of the same book. All your cells right now have the exact same DNA, the same complete instruction manual. But a cell destined to be part of your heart reads only the heart chapter and folds itself into a muscle that will beat tirelessly for 100 years. A cell destined to be part of your eye reads the eye chapter and begins to build a lens, a transparent living crystal designed to gather light. A cell in your bones reads the bone chapter and learns to draw calcium from your blood to build a scaffold strong and light. And the brain, a cluster of cells, began to read the most complex chapter of all, learning to reach out to each other, to connect, to form a network that would one day hold your memory of this very moment. There is no conductor. There is no master architect standing over the plans. The orchestra assembles itself, the music plays itself. The symphony of life emerges from a few simple rules and a chain of events set in motion billions of years ago. And as this process unfolds, something even stranger happens. The developing form, your tiny growing body, begins to tell a story. It remembers, it replays its history. For a brief time in the earlier stages, the human embryo looks almost indistinguishable from the embryo of a fish or a chicken or a turtle. It develops structures that look like gill slits, not because it will ever breathe water, but because the genetic recipe that builds a human face is a modification of the ancient recipe that once built gills. It develops for a time a tail, a small extension of the spine which later fuses to become the coccyx. You are not just descended from these creatures. In a very real developmental sense, your body remembers being them. You are a living archive of evolution. You are the accumulated wisdom of 4 billion years of life, all unfolding from that one single cell. And from that one cell came the most complex object we have ever discovered in the universe. The structure now listening to my voice, the human brain. We are taught to be amazed by the size of the cosmos, by exploding stars and vast galaxies. But the universe inside your skull is just as staggering. You are carrying around roughly 86 billion neurons. 86 billion. That is a number on the same scale as the number of stars in our home galaxy. Each one of these neurons is a living complex cell, a tiny biological computer, and each one of them is connected to thousands of others. The number of possible connections, the web of pathways in your mind, is staggering. It is more than all the stars in the Milky Way. It is the universe of complexity. And yet, the most astonishing thing about the brain is its efficiency. All of it. Every thought you have ever had. Every memory from your first day of school to what you ate for breakfast. Every dream, every fleeting image, every word you understand. The rhythm of your breathing, the beat of your heart, the intricate simulation of the world you see around you. All of it is being run on about 20 watts of power. 20 watts. That is the energy of a dim light bulb, a nightlight. Think about that. The most powerful supercomputers we have ever built. Machines that fill entire warehouses, that drink megawatts of electricity, that require vast liquid cooling systems. They can only just begin to simulate a tiny fraction of a human brain, and they do it thousands of times slower than the real thing. And even then, they are not aware. We can build a machine that calculates, but we cannot build one that feels. We can build a machine that processes data, but not one that experiences. It doesn't know what it's doing. Your brain does, on 20 watts. This is the great mystery, the hard problem of consciousness. We can trace the pathways. We can see which parts of the brain light up when you feel happy or sad or recognize a face. We know the biology, but we have no idea how simple matter, how a collection of cells following the laws of chemistry and physics suddenly wakes up. How does a physical object become a subjective experience? How does a collection of atoms forged in a star look back at the stars and wonder where it came from? We don't know, but it happens. It is happening in you right now. Your brain is not a static thing. It is not a finished sculpture. It is a living plastic flowing river. It is constantly rewiring itself. Every time you learn something new, every time you have a new experience, tiny connections are formed or strengthened or weakened. To learn is to physically change the structure of your mind. To remember is to walk down a pathway that you yourself have built. Your entire reality is a story being told to you by these 86 billion neurons. The light you see isn't light, it's an electrical signal translated from your retina. The sound you hear isn't sound. It's a vibration in the air turned into a different electrical signal. Your world is a beautiful, stable, high-fidelity simulation running in real time on a 20-watt biological machine. But what is a thought if the brain is the machine? What is the ghost that moves through it? What is this awareness that you experience as you? It is electricity. Your thoughts are not just abstract concepts. They are physical events. They are tiny, tiny surges of voltage. A storm of electrical pulses travelling down axons leaping across synapses. A thought is a pattern of firing. A memory is a pattern reignited. Your brain is constantly humming with this activity. We can even listen to it. An EEG, a machine that places electrodes on the scalp, isn't reading your thoughts. It's reading the rhythm of your thoughts. It's listening to the collective synchronized hum of millions of neurons firing together. When you are in a deep, dreamless sleep, your brainwaves are slow, powerful, and rolling. These are delta waves. When you are relaxed, perhaps meditating or just drifting off like you might be now, your brain is in an alpha state. A calm, steady rhythm. When you are awake, alert and focused, your brain is buzzing with faster beta waves. But you, your conscious unified self, that seems to be something else. It seems to be what happens when different distant parts of the brain synchronize their firing. It's called coherence. It's as if your brain is a vast orchestra with sections for sight, sound, memory, and emotion all playing their own tune. Consciousness is the moment the entire orchestra locks onto the same rhythm, playing the same piece of music. When that synchronization happens, you emerge. You are the music, you are the coherence. You are the harmony of these billions of cells all firing in unison. And when that synchronization breaks, awareness fades. This is what happens under anesthesia. The drug doesn't turn off your brain. The neurons are still firing, but they can't talk to each other. They can't synchronize. The orchestra dissolves into a chaos of individual musicians, each practicing their own scale. The music stops, and the you disappears. You are a storm. A slow, structured, self-aware storm of electricity held inside a shell of bone. A 20-watt miracle born from a single cell replaying the history of the world. This is one kind of architecture, fast, complex, individual and defined by thought. But the universe is endlessly creative. It has built other kinds of intelligence, other forms of life that are just as magnificent, but built on entirely different rules. Let's travel just for a moment to a forest in Oregon in the Blue Mountains. You could walk there for an entire day through the pines and the quiet. You might see mushrooms poking up from the forest floor. You might think they are separate individual things, but you would be wrong. You would be walking on the back of a giant. Beneath your feet, hidden in the dark soil, is the largest living organism ever found on Earth. It is not a whale. It is not a giant redwood tree. It's a fungus. Its name is Armillaria ostoyae, and it is enormous. The mushrooms you see are just the fruit like an apple on a tree. The organism itself is the mycelium, a vast, intricate network of white thread-like structures woven through the earth. This single network stretches across nearly 9 square kilometers, almost 4 square miles, and all of it is genetically identical. It is one single being. We have estimates of its age. It has been there silently growing for at least 2,400 years. It may be much older, perhaps 8,000 years old. It was alive before the Roman Empire was founded. It was spreading its slow, quiet tendrils through the earth before the pyramids of Giza were built. It has been there all this time while civilizations have risen and fallen above its head. And it is not just there. It is active. This fungal network is the nervous system of the forest. It fuses with the roots of the trees connecting them. It forms a kind-out underground marketplace, a wood-wide web. Through this network, trees can communicate. Not in words, of course, but in chemistry. An older, taller tree can send nutrients, carbon and sugar through the fungal web to feed a younger seedling struggling for light. A tree under attack by insects can release a chemical warning, a distress signal that travels through the network to warn other trees who then raise their own chemical defenses. This fungus is not just a creature, it is a place. It is an intelligence. But it is an intelligence of a different order. Our brain is fast, hot and electric. It operates in milliseconds. This fungus is slow, cool and chemical. It operates in seasons, in decades. It thinks in trees and soil and time. It is a distributed consciousness, a vast single, ancient mind hidden in the dark. We are so used to associating life with movement and intelligence with speed, but here is a being the size of a city with the lifespan of an empire that does not move, that does not speak, that simply is, a silent living presence woven into the fabric of the earth. The architecture of life is not just one design, it is a library of possibilities, from the electric storm in your mind to the slow fungal web that is the forest. And all of it, all this incredible complex machinery, the brain, the fungus, the cell, it had to be built from something. The raw materials for life, where did they come from? To answer that, we must leave the earth and look up into the deep dark quiet of the sky. We have looked inward to the illusions of our own bodies. We have looked outward to the stellar furnaces that forge the atoms we are made of. We have found our connection to the cosmos, a direct lineage from the hearts of dying stars. But now we must ask an even stranger question. We have talked about what we are and where we came from. But what about when we are? We live our lives immersed in a flow, a current that we call time. It feels constant, absolute. A second for you is a second for me. The past is gone, the future is yet to come, and we exist together in this single, fleeting, universal moment called now. It is the most fundamental experience of our reality, and like touch, like solidity, it is an illusion. Time is not a universal clock. It is not a river that flows at the same speed for everyone. Time is personal, it is flexible, it stretches and it bends. Einstein was the first to show us this. He realized that time is not separate from space, they are woven together into a single four-dimensional fabric space-time. And this fabric is not a rigid stage. It is dynamic, it can be warped. It is warped by speed. If you were to travel in a spaceship very, very fast, close to the speed of light, time for you would physically slow down. From your perspective, everything would feel normal. Your heart would beat at its usual pace, your thoughts would move at their usual speed. But if you flew for what felt like 1 year and then returned to Earth, you might find that 10 years or 100 had passed for everyone you left behind. You would have travelled into their future. This isn't science fiction, this isn't a theory, it's a measured, proven fact of our universe. We see it in particles in our accelerators. We must account for it every single day in our GPS satellites. The clocks on those satellites orbiting high above the Earth are moving fast. And because of their speed, their clocks tick just a little bit slower than the clocks down here on the ground. But that's not the only thing affecting them. Space-time is not just stretched by speed, it is bent by gravity. Mass, any mass like our planet Earth, creates a dipper curve in the fabric of space-time. It's like placing a heavy ball on a rubber sheet, and time itself, time has to follow that curve. The closer you are to a massive object, the deeper you are in its gravity well, the slower time passes for you. This means that time is literally passing at a different rate for every single person on Earth. Someone living at sea level closer to the centre of Earth's mass is aging just a fraction of a second more slowly than someone living on a mountaintop. It is an infinitesimal difference, you would never ever feel it. But it is real. We know it's real because those same GPS satellites have to account for this too. While their speed slows their clocks down, their position far away from Earth's gravity speeds their clocks up. And this gravitational effect is even stronger than the effect from their speed. If we didn't correct for this, if we didn't account for the fact that time is flowing faster in orbit than it is on the surface, our navigation systems would fail in minutes. Your map would drift by kilometers every single day. So when you ask what time is it, the answer is it depends. It depends on where you are. It depends on how you're moving. Every clock in every city, on every mountain, in every airplane is ticking at its own unique personal rhythm. Your life is unfolding at its own private speed. And this leads to something even more profound, something that can be truly unsettling to think about. If time is relative for everyone, what does that mean for now? We have this deep intuition of a universal now. We feel that right now, as you are listening to this, someone in another city is also in this now, and someone on the moon and someone in the Andromeda galaxy, that there is a single slice of time, a present moment, that cuts across the entire universe. Relativity tells us that this does not exist. The very idea of simultaneity, of two things happening at the same time, is also relative. It depends on your motion. If you are standing still, you might see two events happen at the exact same time, but another person moving past you in a fast car would see one event happen before the other, and someone moving in the opposite direction would see the sequence in reverse. And the strangest part is, all three of you would be correct. There is no true answer. There is no master clock, no universal now. What this means is, my now is not your now, and our now is most definitely not the now of someone in a distant galaxy. If that galaxy is moving away from us, what we see as their present moment might be what they would consider their distant past, and what they see as our present moment might be our distant future. This shatters our entire picture of time. It suggests that time is not a river flowing from past to future. It suggests that perhaps the past, the present, and the future all exist. It suggests a block universe, a four-dimensional landscape of space-time where every event, your birth, your first day of school, this moment right now, and the moment of your death are all just there, like coordinates on a map. Time doesn't pass, we just pass through it. Our consciousness is like a spotlight moving along this pre-written path, illuminating one moment at a time, creating the illusion of a flow. It means that nothing is ever truly lost. Every moment you have ever lived still exists permanently in the fabric of space-time, but it also means that the future is just as real, just as present as the past. The stage is far stranger than we thought. But what about the actors? What about the stuff that moves on this stage? What about matter itself? If we zoom in, past the cells, past the atoms, to the fundamental particles that make up everything, we find a world that is not just strange, it is nonsensical. It is the quantum world. There is an experiment, a famous one. It is so simple and so profound that it holds all the mystery of this world in one simple setup. It's called the double slit experiment. Imagine a barrier with two thin parallel slits in it, and you have a gun that can fire one particle, say one electron, at a time. Behind the barrier you have a screen that will record where each electron lands. If you close one slit and fire the electrons, you get what you'd expect, a single band on the screen right behind the open slit. The electrons act like little bullets. If you close the other slit, you get the same thing, a single band behind that slit. Now, what happens if you open both slits? You would expect to see two bands, one behind each slit, but that is not what you see. What you see is an interference pattern, a whole series of bright and dark stripes spread across the screen. This is the pattern that waves make. It's the pattern you'd see if water waves passed through both slits, with the peaks from one slit adding to the peaks from the other, and the troughs cancelling out the peaks. But you were firing one electron at a time. How can a single particle create a wave pattern? How does it interfere? What is it interfering with? The only possible answer is that the single electron, somehow, went through both slits at the same time. It didn't choose a path. It existed as a wave of probability. It spread out and it took all possible paths. It interfered with itself, and it only landed on the screen when it had no other choice. This is called superposition. The idea that at the quantum level things are not in one definite state. They are in all possible states at once. An electron isn't here or there. It is in a smudge of here and there until you look. And that is the weirdest part. If you put a detector by the slits, if you try to watch and see which slit the electron actually goes through, the interference pattern vanishes. The moment you observe it, the moment you ask the universe to make a choice, the electron stops being a wave. It collapses. It picks a slit. It acts like a little bullet again, and you get two simple bands on the screen just as you'd expect. It's as if reality doesn't commit. It's as if the universe is made not of things, but of possibilities. At the smallest scale, the world is not solid and definite. It is a fog of probability, a blur of overlapping potential. And it only solidifies into the real world we know when something, an observation and interaction, forces it to choose. Think about that. Every particle in your body, every electron in every atom, exists in this state of quantum uncertainty, this cloud of maybe, right up until the last possible second. The universe is constantly making choices, collapsing from a wave of infinite possibilities into a single concrete now. This is the foundation of everything you see. The solid chair you sit on, the very floor beneath you. It is all built on a bedrock of pure undecided potential. This strange nature of particles, their identical blurry wave-like quality, led to one of the most beautiful and strange ideas in all of physics, a philosophical guess from a physicist named John Wheeler. He was thinking about electrons, and he was bothered by something. Every electron in the entire universe is identical, not just similar. Identical. Every single one has the exact same mass, the exact same charge, the exact same spin. We have never found one that is even slightly different. This is odd. In the big world, no two things are ever truly identical. Every grain of sand is unique. Every snowflake is different. But in the quantum world, identity is perfect. So Wheeler had a radical thought. What if the reason they are all identical is because they are all the same one? What if there is only one electron in the entire universe? He proposed that this single electron is weaving its way through space-time. It travels forward in time, and then at some point it turns and travels backward in time. And then it turns again and goes forward. It is zigzagging, creating a single tangled knotted thread that stitches the entire cosmos together. Every time we see an electron in every atom, in every star, in every living cell, we are just seeing a different point on the timeline of this one single particle. Your body, according to this idea, is not made of trillions of different electrons. It is made of trillions of intersections of this one ancient time-traveling electron. And the antimatter, the positron, Wheeler said, that's just the electron moving backward in time. Now, this is not a mainstream accepted theory. It has problems. It doesn't, for example, explain why there is so much more matter electrons than antimatter positrons in the universe. But even as a wrong idea, it is beautiful. And it points to a deeper truth that is part of quantum mechanics, the indistinguishability of particles. In the quantum world, particles do not have identity in the way we do. You cannot label electron A and electron B. If you swap them, the universe does not and cannot know the difference. There is no change. It's not like swapping two tennis balls. It's like there is only one electronness, one electron field, and the particles we see are just ripples or knots in that single underlying field. So perhaps Wheeler was right in spirit, if not in detail. Perhaps the universe is not made of billions of separate individual things. Perhaps it is made of just a few fundamental ideas. And we are just a complex pattern, a temporary dance of those few unified mysterious fields. The stage is a flexible personal fabric of space-time. The actors are just blurs of probability, echoes perhaps of a single underlying truth. And this is the reality we are floating in. We have been on a strange journey down into the quantum fog that holds the illusion of our world together. We have learned that the stage we walk on is not fixed, that time itself is personal, and that reality at its very root seems to be a landscape of pure, unchosen potential. Now, let us lift our gaze. Let us pull back from the microscopic, from the electron's uncertain path, and look out past the moon, past the neighbouring planets, past the dim light of our own sun, out into the grandest scale we can possibly imagine. We spoke of the atoms in our bodies, the stardust, but we have not yet spoken of the sheer impossible number of stars. There is an old thought, a comparison, and you may have heard it before, but I invite you to truly feel it for a moment. Picture a beach, the sand beneath your feet. Try to imagine counting the grains in a single handful, thousands, perhaps tens of thousands. Now imagine all the sand in that one handful and then in a bucket, and then all the sand on that one beach stretching from the dunes to the water. The number becomes meaningless, it is just many. Now imagine all the beaches on Earth, every coastline, every island, every hidden cove, and now add all the deserts, the Sahara, the Gobi, every vast sea of sand. Try to hold that number in your mind, the number of all the grains of sand on the entire planet. It is a number that is for a human mind essentially infinite, and yet there are more stars in the universe than that. Not just a few more, not just double, orders of magnitude more. For every single grain of sand on Earth, in every desert and on every beach, there are in the sky at least 10,000 stars. It's a number that breaks the mind, and we didn't always know this. For most of human history, the universe was just the stars. We could see a few thousand glittering points in our own small neighborhood. For a long time, we thought our galaxy, the Milky Way, was the entire universe. And then we built better eyes. In '95, astronomers did something that sounded at the time like a beautiful waste of time. They pointed the Hubble Space Telescope at nothing. They found a patch of a sky near the Big Dipper that looked perfectly, absolutely empty. A black silent void smaller than a pinhead. And they aimed the most powerful telescope ever built at that patch of nothing, and they just stared. For 10 days. They let the telescope's eye stay open, gathering every faint ancient photon that might be drifting from that void. And what came back was not to darkness. What came back was a tapestry, a photograph that changed humanity's place in the cosmos forever. It was filled wall to wall with light, but the lights were not stars. They were galaxies, thousands of them, in that one tiny empty speck of sky, each one a swirling city of light containing hundreds of billions of its own stars. Some were ancient red and dying, some were young blue and bursting with new life. We call it the Hubble Deep Field. It is a photograph of just 1/24 millionth of the whole sky. It is the celestial equivalent of looking at a single grain of sand and seeing a universe inside it. That is the scale. We are one planet orbiting one star in one galaxy, among trillions. So, if this is the scale, what is the shape of the thing that holds it all? What is the geometry of the cosmos itself? It's a strange question to even ask. We are used to things having edges. A room has walls, a planet has a surface, but what about everything? Cosmologists have two main possibilities. One is that the universe is flat, like a perfectly flat, infinite sheet of paper. In this version, the universe goes on forever. If you were in a spaceship, you could fly in one direction forever, and you would just keep going. You would pass new galaxies, new clusters, new worlds infinitely. You would never stop and you would never turn back. The other possibility is that the universe is closed, that it is finite. But this is where our intuition fails us. Because if it's finite, our minds immediately ask, well, where is the edge? What is outside of it? But that is the wrong question. The mathematics suggests something far stranger. The universe could be finite, but have no edge, no boundary, no outside. How can there be? Let's use an analogy. Imagine you are a two-dimensional creature. You can only see flat in front, behind, left and right. You live on the surface of a giant sphere like the Earth. You start walking in one direction, believing you're on a flat, infinite plane. You just keep walking in a perfectly straight line. You walk for days, for years. You never hit a wall. You never find an edge. And then one day, you look up and you see the back of your own head. You have returned to where you started. For you, the two-dimensional creature, your universe was finite, but it was boundless. You could walk forever and never fall off. You never found a center and you never found an edge. Now, take that idea and apply it to us. We are three-dimensional creatures. We see in length, width and depth. What if our three-dimensional universe is just the surface of a four-dimensional hypersphere? It would mean that you could get in a spaceship and fly in one perfectly straight line, past the moon, past Andromeda, past the edge of the Hubble Deep Field. You would fly for billions of years. You would never hit a wall. You would never find a boundary. And eventually you would end up right back where you started. Which one is it? Is the universe flat and infinite, or is it curved, finite and boundless? When we look, when we take our measurements, it appears to be almost perfectly flat. But that too could be an illusion of scale. If you are an ant standing on the surface of a balloon the size of the Earth, the ground beneath your feet would look perfectly flat. The curvature would be so subtle, so vast that you could never perceive it. We might be those ants. Our universe might be curved, but on a scale so enormous that to us in our tiny observable pocket, it just looks flat. And in either case, whether it is an infinite sheet or a finite sphere, there is one more profound truth. There is no center. We are trained to think of the Big Bang as an explosion, something that happened in space. A single point that blew up, sending galaxies flying out into a pre-existing emptiness. But that is not what happened. The Big Bang was not an explosion in space, it was the unfolding of space itself. It did not happen over there in a particular spot, it happened everywhere. It happened in the space that your body now occupies. It happened in the space between your house and the moon. It happened in the space occupied by the farthest galaxy we can see. Space itself stretched. It expanded. It didn't expand into anything because there was no outside for it to expand into. There is no center of the universe because everywhere is the center. This is the shape, the geometry of our reality. A vast, perhaps infinite, edgeless, centerless everything. But what is it if this is the shape? What is the substance? And here in the last few decades, physics has offered an idea so radical, it sounds like pure fiction, but it is rooted in the deepest mathematics we have. It is called the holographic principle. It suggests that all of this, our three-dimensional reality, might be a projection, a hologram. This idea started as many strange ideas do with black holes. There was a paradox, a puzzle. According to the laws of physics, information can never be destroyed. It can be scrambled, hidden, or rearranged, but not truly lost. But what happens if you throw something, say a book, into a black hole? The book and all the information it contains seems to fall inside and vanish forever. The information is destroyed. This bothered physicists deeply, and a solution was proposed. What if the information never actually falls in? What if, as the book falls toward the black hole, all the information that makes it a book, its atoms, its letters, its structure, gets stuck on the boundary? What if it is smeared out and encoded on the 2D surface of the black hole, the event horizon? In this idea, the black hole itself, the 3D volume inside, is just a projection, a hologram. The real information lives on the 2D surface. And then someone took the next logical, terrifying step. If this is true for a black hole, why not for the universe itself? What if our entire universe, this vast three-dimensional cosmos, is just a holographic projection? What if all the information that makes you and makes a star is actually encoded on some vast, distant, two-dimensional surface that surrounds us? This doesn't mean the universe is fake. This chair is real, your hand is real, but it might mean that this 3D reality is not the fundamental reality. It is an emergent property, a derivative, a beautiful complex 3D hologram projected from a 2D source code that lives on the boundary of space and time. It suggests that the deepest laws of physics might not be written for 3 dimensions. They might be written for 2, and that we are the movie. And that leads to the final dizzying question of scale. If our universe is this vast, strange holographic place, is it the only one? The mathematics, again, suggest probably not. There are 2 major theories that lead to this conclusion. The first comes from that expansion, the Big Bang. The theory of cosmic inflation says that in the very first fraction of a second, the universe expanded faster than the speed of light. Space itself stretched, smoothing out all the wrinkles. This is what made our universe so big and flat. But some models of inflation suggest that it never completely stopped. They suggest that inflation is eternal, that it is still happening out there in some vast meta-space, and every so often a little pocket of that inflating space stops. It cools down, it buds off, and a new universe is born, like a soap bubble forming in a bath. In this model, our entire universe, all the trillions of galaxies, all the sand, all the stars, is just one single bubble. And all around us, inaccessible, unreachable, new bubbles are forming constantly. And in these other universes, the laws of physics might be different. Maybe gravity is stronger, maybe light is slower, maybe atoms never form at all. Most would be sterile, empty and dark, but some might be even more complex than ours. We are one universe in a multiverse. And there is a second path to this idea, one that comes from the quantum world, from the double-slit experiment. Remember how the electron existed in all possible states at once until it was observed and collapsed into one reality. The many worlds interpretation asks a different question. What if it doesn't collapse? What if, every time a quantum choice has to be made, the universe splits? What if when the electron hit the barrier in one universe, it went through the left slit, and in another parallel universe, it went through the right? In this view, all possibilities happen. The universe is constantly branching like a tree into an infinite number of copies of itself. This means that there is a universe where you did not lie down to listen to this. There is one where you turned left this morning instead of right. A universe where you took that job or said that thing you wish you had. Every quantum event, every tiny random fluctuation spawns a new entire world. We are living in one branch of an infinitely branching tree of realities. We cannot prove it. We cannot yet visit these other bubbles or these other branches. They remain for now beautiful, haunting ideas born from our mathematics, but they are the logical conclusion of where our physics has taken us. From a universe of a few thousand stars to one of trillions of galaxies, to one where our entire 3D reality is a projection, to one where our entire universe is just one bubble or one branch among an infinite sea. That is the grandest scale we have yet conceived. And yet, here we are, in this one, this branch, this bubble, this hologram, and in this universe of ours, 95% of it is still invisible. We have journeyed to the grandest scale, a cosmos of infinite branches, a reality that may be a hologram, a universe of such vastness that our minds can only touch its edges. And yet after all this, the greatest mystery is not what we see, it is what we don't. We have found that 95% of our universe is invisible. It is missing, or rather it is present, but it does not play by our rules, it does not touch light, it does not reflect or shine or cast a shadow, it is there, but it is dark. Let's start with the void, the nothing in between. We think of empty space as just that empty, a passive, silent, cold vacuum. But in the strange rulebook of quantum mechanics, there is no such thing as nothing. Even in the most perfect vacuum, if you could zoom in, far past the atoms, past the electrons, you would find a place that is not still. It is seething. It is a restless, bubbling foam of potential. This is the quantum vacuum, and out of this emptiness particles are constantly bursting into existence. Pairs of them, a particle and an antiparticle. They flash into reality, exist for a fraction of a second, and then they collide and annihilate each other, vanishing back into the nothing they came from. We call them virtual particles. They are a constant restless shimmer just beneath the surface of reality. This isn't just a theory, it has real measurable effects. If you take two mirrors and place them incredibly close together in a perfect vacuum, they will be pushed toward each other, not by any outside force. They are pushed together by the nothing outside of them. The vacuum energy, the pressure of the void, is real. So even the emptiness is full of energy, but that is not the only thing that is hidden. When we look at galaxies, like our own Milky Way, we see a strange problem. The stars on the outer edges are moving too fast. Far too fast. Based on all the stars and gas and dust that we can see, based on all the gravity that should be there, these outer stars should simply be flung off into the darkness. The galaxy should tear itself apart. But it doesn't. It holds together. There must be something else there. Something with mass. Something with a lot of gravity. Something we cannot see. We call it dark matter. It is not just a little bit of stuff. It makes up about 27% of the entire universe. All the stardust we talked about, all the atoms that make you and me and the planets and the stars, all of it, that is only 5%. We are the afterthought. This dark matter is the real substance of the cosmos. It is the invisible scaffolding. It is the vast unseen web that connects the clusters of galaxies. The visible light, the galaxies we see in the Hubble image, they are just the foam, the glittering lights collected in the invisible gravity wells of this dark matter skeleton. We don't know what it is, but it is there holding us together. And then there is the other 68%. In the 1990s, astronomers were trying to measure how fast the universe was expanding. They assumed logically that the expansion was slowing down. Gravity, after all, pulls things together. The universe should be putting on the brakes. They pointed their telescopes, they took their measurements, and they found something that no one was prepared for. The expansion is not slowing down, it is speeding up. Space itself is stretching faster and faster every single day. Something is pushing it apart. Something is acting like a kind of anti-gravity built into the very fabric of space itself. We have no idea what it is. It is the most profound mystery in all of physics, so we gave it a simple, humble name. We call it dark energy. This is not a small force, it makes up nearly 70% of everything that exists. It is the dominant force in the universe. And it is this force, this invisible repulsive energy, that will decide our ultimate fate. This brings us to the end, or the beginning. Our concept of time, as we've seen, is fragile, but it is not eternal. Time itself had a beginning, the Big Bang. That moment when our universe unfolded from a single point. That was not just the beginning of matter and space. It was the beginning of time. There was no before, because before is a concept that only exists within time. Time itself was born in that fire. And if time had a beginning, it will almost certainly have an end. That end will be dictated by this great cosmic battle. The gravity of all the matter, visible and dark, pulling the universe in, versus this mysterious dark energy pushing it out. Based on what we see now, dark energy is winning. And this leads to two possible futures. The first is the heat death, or the big freeze. If dark energy is constant, a gentle, persistent push, the universe will just keep expanding. The galaxies will fly further and further apart beyond our horizon, vanishing from our sight one by one. The stars within our own galaxy will burn out. One by one, their fires will die. The universe will grow cold and dark. The last red dwarfs will flicker and fade. Black holes will slowly, over trillions upon trillions of years, evaporate into nothing. Even matter itself may decay. What will be left is a vast, cold, empty, and perfectly silent universe. A thin soup of stray particles separated by infinite distances, cooling toward absolute zero. A place where nothing ever happens again. And in a universe where nothing happens, does time even have meaning? It is a quiet, lonely, and peaceful end. But there is another possibility. What if dark energy is not constant? What if it is growing stronger? This is called the Big Rip. In this scenario, as dark energy grows, its repulsive force becomes dominant over everything. First, it will overcome the gravity that holds clusters of galaxies together. They will drift apart. Then, as it grows stronger still, it will overcome the gravity holding individual galaxies together. Our Milky Way will be torn apart. Then the force will be strong enough to overcome the gravity holding stars to their planets. Our solar system will be unbound. The Earth will be flung into the dark. In the final terrifying moments, the force will become stronger than the chemical bonds that hold us together. Molecules will be ripped apart, and in the last fraction of a second, it will become stronger than the forces that hold atoms together. The nucleus itself will be torn apart. Space-time, the very fabric of reality, will be ripped to shreds. The end of not just matter, but of space and time itself. We don't know which it will be, the cold, slow fade, or the violent, sudden tear. And here we are, you and I, here in the middle, not at the beginning, not at the end. We live in this brief, warm, luminous sliver of cosmic history, when the stars are still burning and the universe is still full of life and possibility. We are the stardust. We are the atoms forged in the hearts of stars that died billions of years ago. We are the walking colonies, the ecosystems of trillions living in harmony. We are the 20-watt miracles, the electrical storms of consciousness that learn to look up at the night sky. We are a pattern, a brief arrangement of matter that has for a short and precious time woken up. We are the universe, becoming aware of itself. We are floating in a cosmos of 95% invisibility on a stage of holographic quantum rules in one possible branch of an infinite tree. We are made of the emptiness we see, and we are glowing with a light we cannot. It is a mystery. It is perhaps the most beautiful mystery of all. And you are a part of it. You are not separate from it. You are it. And now, there is nothing left to do, nothing to solve. Just the quiet, the dark, and the knowledge that you are a child of the stars resting for a moment in a universe that is dreaming of itself. Rest well.